everyone, today we are talking about activity 3 and the recursive formula. Now, what is the recursive formula or the recursive sequence compared to what we have been talking about, the explicit formulas? Well, recursives are a sequence of numbers created by a defining term. Usually we call that a sub 1. Occasionally you'll see that as like a sub 0. It officially could be any value, but we tend to use the first term in this class. And basically we are looking at the pattern. So it could be addition and subtraction like arithmetic, multiplication / division like geometric. It could be a combo with a 2, or none of the above entirely. But basically what we are doing is we are creating a sequence using the previous term, or sometimes even terms, plural, to get our sequence. So we're involving the previous term, a sub n minus 1, usually, right? Although occasionally you might see other terms. Like I said, you might see maybe a sub n minus 2 or a sub n minus 3. We'll look at some examples where we involve that as well. Now, when we write the recursive formula, okay, again, it has to relate to the previous term. So you must state each time the first term, all right, or your initial term in which you are starting your sequence off with. This requires our formula then to also state what's happening. So to get our current term, what is happening to our previous term or terms. So there's some pros to this. We can use it for arithmetic, we can use it for geometric, but we can create other sequences entirely that are involving our previous terms that we may not be able to write a specific rule for. Cons, we must have the first term and or the previous term. So it's kind of inconvenient. If I want term 100, I would need the first 99 in order to be able to actually solve for that. There's no direct way. Now, the explicit formula is what we've been dealing with. So for instance, for an arithmetic, that's our first term times the common difference times n minus 1. Geometric, first term times our R value to the n minus 1, right? So we've seen that previously. It does not require us to list that first term, although it is involved in part of our formula. So some pros to this is that we can find a large term without needing to find all the terms before it. However, some cons, we only have shortcuts for arithmetic and geometric. We are kind of limited to only talk about those with an explicit formula with the actual rule. Otherwise, it takes a little bit more work to come up with that. So it limits us. Now, how do we use this? Okay, so each time when you have a recursive formula, they are going to state for you your first term and then what you are doing each time in your sequence using the previous term. So to get my current term, I'm going to take my previous term and add 4, aka that's my common difference, right? This is arithmetic. So I'm going to add 4 to get 12, 16, 20, and 24 as terms 2, 3, 4, and 5. Now in my next sequence, they gave us a starting term, this time of 5. And then this time, this is geometric. So notice to get our current term, we take 2 times our previous term. So 5 times 2, 10 times 2, 20 times 2, and 40 times 2 to get our first 5 terms of that sequence. Now on the next page, you are going to see 2 examples. The first one, part A, you are going to find the first 5 terms, and then similar for part B, use the recursive to find the first 5 terms. Now example 3 is where we start seeing why is this useful to us to have recursive definitions, because notice the sequence here. We're doing addition and some multiplication, and essentially what we're doing each time is we are taking the term previous and then 3 terms previous times 2 and summing those 2 values together. Now notice our chart, they're kind of giving us term 1, term 2, term 3, aka these are our values for term 1, term 2, term 3 for those ends, but then they jump to term 6 and term 8. And our goal here is to find terms 4, 7, and 9. So in order to find term 4, we are taking the term previous, so term 3, and then adding on to it 2 times 3 terms previous. So 4 minus 3, that would be term 1. Well, according to our chart, term 4 is 4. And then according to our chart, the first term is 2. So 4 plus 2 times 2 is 8. In order to find term 7, then, we need to take the previous term, which is term 6, and then add on to it 2 times 3 terms previous, right, of term 7. So that is term 4. So term 6, we said from our chart, is 22. And then term 4 from up above, we got that to be 8. So 22 plus 16 is 38. Right, last but not least, we are looking for term 9. So again, we're going to take that term previous and then 2 times 3 terms previous, which is term 6. Term 8 from our chart is 66. And then 2 times our 6th term, which from the chart is 22. So 66 plus 44 is 110. So again, we can see why the recursive is a useful formula, because we can use those preceding term values to find patterns in our sequence, just not necessarily arithmetic or geometric. Now, example 4 does have us actually jumping back then to arithmetic and geometric, because what we notice is in number 4a, we have a geometric sequence with an R value of -2. Now, in order to define something recursively, you need the rule, and you definitely must put each time the first term. So in this case, we are starting off with 3, and then to get our current term, we take that R value of 3 and multiply it by our previous term each time. Oh, I'm sorry. Take the R value of -2 and multiply it by our previous term, right? Because R was -2. Now, this second one is an example of an arithmetic. And each time to get our next term, we are subtracting 1. So we're going to, again, start this off always by listing your first term. And then this time, to get our current term, we take our previous term and subtract 4. All right, there are 2 more for you to try. The next one, you are finding the recursive formula for part C. And then you are also going to find the recursive formula for part D. Always remember both parts. Now, last but not least, again, the recursive formula goes beyond some of the examples we saw above with arithmetic and geometric, but we can use not only 1 term, but even 2 terms previous to find our different sequence. So notice this time, because we are using 2 previous terms, we have to list the first 2 terms. Because in order to find the third term, I'm taking the previous term and then 1 more previous term, so in this case 1 and 1, adding them together to get my next value. So then I would take term 3 and term 2, add those together. So term 3 we had was 2, term 2 was 1, we get 3. Previous term, and then the second previous term, so in this case 3 and 2, we get 5. And what we have here is actually a famous sequence that is called the Fibonacci sequence. And what this sequence does is it takes the preceding values, and in order to find the next term, we add up our 2 previous terms. So each time, we again are just taking those 2 previous, adding them up to get our next term. And again, this is something that we couldn't do explicitly. Recursive formula works out best. Thanks everyone for watching. We'll work more with activity 3 as a whole in class.